Hey folks, welcome back to the Driving Game series. In this session, we're going to be having a look at how we can set up the chassis for our trucks. Why are we doing it this way? Well, when you're building a game, it's useful to be able to pass around a certain amount of data between things. And as well, the way that we want to build this is we want to be able to have as many trailers on our truck as we want. We want to be able to use whichever mesh we want for our truck. And the only way that that's really viable is if the truck itself or the vehicle itself is an instance. Then we don't have to process every single of potentially millions of vertices on that mesh through geometry nodes. So what we're going to be doing is a multi-layered approach here. Different parts of our game system are going to be stored in their own object. For example, we're going to have a UI element. We're going to have a score manager. We're going to have a game manager, and we're going to separately keep the vehicle. So what we're interested in here is creating a chassis system that is going to be what is simulated in our game, so that we don't need to actually think about the wheel meshes, the car meshes. We can just think about points of splines and raycasting them down to the terrain to simulate our collisions, our towing mechanics, so that we have that nice trailer chain and all the sorts of things like that. So this is all going to come through just chassis. So in this session, we want to set up our chassis objects for the cab and for the trailers. And then we're going to have a look at how we can attach them together into a chain of chassis in our game manager, where the game will actually happen. To begin with here, we're going to be starting off by taking our cube and our light from our collection. We're going to delete them. Let's bring this now empty collection down, and we're going to rename this one to game objects. Now we want to add another collection into our scene collection, so same level on here as at the other collections, and this one is going to be called chassis. That's CHASSIS. Inside the chassis collection, we're going to add two collections. One is going to be called cab chassis, and the other one is going to be called trailer chassis. Now, the reason that I'm doing these as collections rather than just an individual object is because we're going to also allow you within the game to sort of swap out the skin of your vehicle. Now, I'm not actually going to implement it, but I am going to signpost you to where you can start setting this up. So for our case here, we're just going to use a single chassis, but that'll be very easy because we're using instancing to just pick a different index. So you could have maybe the sci-fi truck that I'm going to be giving you, but maybe you also want a car with a caravan. Maybe you want a motorbike with a little trailer. Maybe you want something else entirely. Maybe you want to make your own spaceship with its cargo trailers. So super flexible way of working here, and it's taking advantage of a lot of nice native Blender stuff. In the cab chassis collection, go ahead and add a plane. We can just go and delete the mesh from that object. We don't need it at all. It's going to be generated inside geometry nodes. Jumped over into my geometry node setup here just so that we can work with our nodes, and let's rename our object here to 01 just to make sure it shows up at the start of the list, underscore cab underscore chassis. Let's make a new node tree, which we're going to be calling chassis. And in here, we need to start off by creating our chassis mesh, which is actually going to be a curve. So we're going to be adding, first of all, a curve, primitive curve line. Now, the way that we want to be working here, let's have a think about this. If we have a vehicle, excuse my crude drawing. So we have a vehicle here, and the direction it's going to be facing is Y plus. So we have the x-axis being sideways, and behind us is going to be Y negative. So when we create our chassis, if we think about our coordinate space up here, we want to make sure that this is the front of it here, and the back of it is over here. So what we're going to do, because we have our curve line, we're going to make sure that index 0 is at the front, index 1 is at the back. And that means that when we add the next spline for the next trailer, it's going to be 0, 1, which when joined together is going to become 2 and 3. So it's going to count up in the correct order going backwards through our object. But it's just important to note that because we are going 0 to 1, the curve tangent is opposite to the travel direction. Not something that we need to think about right now, but just have that playing over in your mind. So the way that we're actually going to be building this, if we think about it a bit more, is we've simplified this right down. This is not going to be a physically accurate game, but it is going to be still fun, and it's going to have elements of natural driving, but it's going to be quite arcadey. So if we have our 2 points of our spline, when we want to create our wheels, we simply have to extend out in each direction and then create a wheel. And we can position it on the ground by simply raycasting down at the terrain at that point. So we have the main spline of our vehicle is the most important one. From that, we can derive everything else. We know which way sideways is because we have the curved tangent in this direction, and we have the terrain normal at the point that we've started sampling it. And that allows us to work out the horizontal axis. So you can get a lot of information by working with splines, and I recommend that when you're building complicated systems, you think about how you can use splines in that workflow because you can start deriving things from them. Let's go ahead here and build the chassis. So we have a curve line. Let's just connect this to the group output. And rather than going in the upward direction, we're going to use direction here on the curve line node. We want to use the -1 on the y-axis so that we are extending it backwards so that we have 0 at the front and 1 at the back. Then the length of this is going to be the length of our chassis. So we actually want to bring back our group input node here. And we're going to expose our modifier as well so that you can see how we build up the information. So first of all, let's just set a reasonable length for a chassis, 5 meters. And I will plug this in as the length. If you press N, go to your group, and then we can start playing with what these are going to be called. So we don't need a geometry input. We can remove that. And the length input here, this is going to be chassis length. Now, every piece of information pertaining to the vehicle, we're going to be storing it on the chassis. And this means that we can hot swap out different chassis and have them simulate correctly, and everything else will be derived from that information rather than storing it in the node trees. So if you're always reading from your chassis, you always know how long your vehicle is, how wide it is, how it's going to connect to the trailer, how big the wheels are, whether or not it's a trailer, for example. So a lot of information you can store here. So we're going to be using our chassis length. And rather than just writing it to the curve line, we're actually going to be storing it as an attribute. So grab a store named attribute node on here. And we want to take our chassis length and plug it into this node. The name of this attribute is simply going to be chassis underscore length, just like this. It's going to be a float on the point domain. Now we're going to do another store named attribute. This one is going to be axle underscore length, and again, float on the point domain. If we add another one, we also want to know how big the wheels are going to be. So let's grab a wheel radius attribute. And additionally, we actually want to know the suspension travel. So it's not going to be perfect how we simulate this, but it is going to indicate a little bit of rock and roll as we go over bumps and things. So let's add suspension travel in here as well. And I'm using full words for my attribute names, and it just makes it much easier when revisiting your node graphs later to see what you are actually talking about. Let's also grab a tow hitch offset. What is this one going to be? Tow hitch offset. So if we think of our spline, let's say this is our main vehicle, and then our next one is going to be a trailer here. If this is our rear axle and our front axle, and this is the point that we want to actually hitch onto that front spline, then, well, this tow hitch offset is going to be however far behind the rear axle, or potentially in front, if you want to go forwards, that tow hitch is going to be. If you think about a car, and again, excuse my drawing, very childish, but the tow hitch is going to be behind the rear axle here. If you are thinking about a lorry, and that can look something like this, then your fifth wheel tow hitch position is actually going to be in front of the rear wheel. So you just got to think about how you want to set this up, because sometimes you're going to want in front, sometimes you're going to want behind. So for example, when we have the next trailer, it's actually going to be mounted behind. So there we go. So this tow hitch offset is just the distance relative to the back wheel, the back axle, that we're going to offset the tow point by. And the next one is actually going to be a Boolean, and this one is going to be called trailer. And this is simply whether or not we are a cab chassis or a trailer chassis. And having this boolean means that I don't need to make a separate node tree for doing trailers. I can simply turn on the boolean that it is a trailer. Now, the last thing that we want to do is control the normal direction. So the normal of a curve, we have our tangent, but the tilt is going to define the normal direction. So we have these two vectors, one in the direction of the curve and the other one at sort of 90 degrees. So side on to the curve. Now we can just say set curve normal, which is under curve right, set curve normal, there we go. And we can set this to Z up. And this is supposedly going to set the curve normal to point upwards exactly. I've had differing successes with this, so we're also going to use a curve right, set curve tilt. And we can come back to this later in order to change this, but this is going to control our steering axis, but we will come back to it in the next session. Let's just put it here so it's set up. Let's plug all of our store named attribute nodes into our group input. So let's make this full screen. That was control space. And we simply need to connect each one of these up. So that is the axle length, the wheel radius, the suspension travel, tow hitch offset, and the trailer. And if you're anything like me, you really like to organize your noodles. I find it just a lot easier to come back to these node trees if they're pretty. So just grab these reroutes, there we go. And let's also make sure that we've named these things on the front of our modifier, just so that we know what we're adjusting. So chassis length, that's already been set up, and we can set a minimum of 0. Reasonably, you're never going to go below probably 2 or 3, but you know, potentially you're doing a remote control car or something at a different scale. So we'll go down to 0 there. Subtype distance. This next one is axle length. And again, subtype of distance. Default can be something sensible like 2 with a minimum of 0. Next one will be wheel radius. Again, subtype distance. Default, let's just set it to 1. That should be a huge wheel, actually. That would be 2 meters across, but let's just leave it as that. Minimum of 0. Next one is the suspension travel. Subtype distance, you get the idea now. Default of 1, minimum of 0. Next one is going to be tow hitch offset, with a subtype of distance. Default is going to be 0, and the min max is going to be negative and positive infinity. So this one, we actually do want to be able to go below 0, because we might want to be in front of that rear axle. Finally, this last boolean here is just going to be trailer, and maybe I put a question mark next to that, just so that we can see that it's an option there. All right, so our geometry nodes modifier now contains all of the information that we are writing onto this chassis. So for example, we might set our axle length to 3 meters, our wheel radius to 0.5, our suspension travel to 0.3, our tow hitch offset to, let's go with 1. And because this is the cab chassis, let's leave our trailer turned off. Now take your cab chassis, duplicate it, move it into your trailer chassis, and let's just rename this one to trailer chassis. And this time we're going to tick on trailer. We might as well leave most of these the same. Let's maybe increase our chassis length here to 8 instead, just so that we can see that there's a difference here. So there we go. Here's our 2 splines. Great stuff. Let's go into our game object now and actually use these for something. So in our game objects collection, let's add a new plane. This one is going to be called Game Manager, and the Game Manager is where the game happens. So first of all, add a new geometry nodes modifier. Let's call this one Game Manager as well. If we have a look at our group menu here, we have controls, chassis, and X input reader. If I were to take something like the chassis and I was to rename it period chassis, then we have a look at our group menu again, it disappears. So starting a name with a period for a data block in Blender hides that data block from the list. So if we don't want our game manager to show up anywhere, we can just start the name with a period. And now it is just this sort of single use thing. And we don't need our group input here. We're just going to be looking for instancing on points. So let's grab our instance on points node. Our point is going to be a points node, just making a single point. And we are going to be instancing at this point a cab chassis. So let's grab our cab chassis collection. As an instance, we'll set this to separate and reset children, just so they're on the origin there. And let's connect this through to the output, make sure that we have that selected. So now we can see this here. Great. So we've instanced the cab chassis. We can rotate it, we can move it up and down. Let's leave these as defaults for now. I also want to make sure that pick instance is on, and we're going to just drag off an integer here. So this is where you would be able to choose which cab chassis you use. We're just going to leave this as 0, but if you want to choose it, this is where you would do so. Now the next thing that we want to do is create trailers and have them link up behind our main chassis here. So after our instance on points, shift right click to make a reroute, control G to make a group, and let's tab back out. And let's rename this one to period because I'm only going to use it once. Create underscore trailers. And then just to keep things neat, let's right click, show hide node options. And there we go. Nice, neat node. Tab back in on the input here. This one's going to be called cab chassis, and the output is going to be all chassis. Chassis is plural for itself, so we can just leave it like that. Let's make a bit of space in here. We're going to be using a loop, which is under utilities repeat zone, to create multiple trailers. So our cab chassis is going to come into the repeat input, and the output is going to come out like so. Now let's think about how we want to do this. We have our chassis coming in. It has a front and a back. We also know that there is a tow hitch offset on here, and we know it's tangent. So what we can do is we can find the position of the rearmost point. We can move it in the direction of the curve tangent multiplied by the tow hitch offset, and that is going to move it forwards or backwards by a set amount in the correct direction. And then once we have that position, then we can simply instance the next trailer on it. Now, if we want to take that trailer and instance another one behind it, then we simply do the same thing. So this is why it's happening inside this loop, but we need to make sure that we're separating these. So we need one pathway where we're joining them all together to actually read out all of the chassis together. And we need one where we're just passing through the previous one in order to make the next loop and make the next loop and make the next loop and so on. So on our repeat input, have this selected, go to your N panel node, and under your repeat section here, let's rename this first one to last chassis. We're going to create a new input, which is going to be called chassis combined. So there we go. These are our two routes that we want. Let's start off by realizing the instance of our last chassis. And then on this, we want to instance on points the next chassis. So let's bring in our trailer chassis collection, separate and reset children, bring those instances into your instance on points node, and we are going to be picking instance. The instance index, let's plug this onto our original group input, and I might actually bring down a special node just for that one. And then if we tab out this, you could also drive off that same version here for which chassis, or let's say skin selection, so that you can use this everywhere to pick different skins. Okay. So we still need to do our movement stuff. And the way that we do this is actually quite simple. So we're going to be taking a geometry right set position after our realize instances. And all we need to do is take a curve read curve tangent node and use a vector math scale to scale it by the stored attribute for the tow hitch offset. So let's use a named attribute node. We're looking for the tow hitch offset attribute, and this comes into our scale. This simply plugs into our offset vector, and now we are moving the whole spline in the direction of the curve tangent. Then all we need to do is make sure that we're only instancing our new trailer on the rear point. So we will use a curve read endpoint selection, and we're only interested in the one final point. So let's plug this into our selection. All right. So if we select our game object, you can see that we've got this point on here, this line now. And if I increase my iterations, you can see that we're stepping back and stepping back and stepping back. So we're not actually joining all of these things together. So we need to have a look at our chassis combined route as well and work something out for that. So we're plugging our instances into that last chassis, but we also need to make sure that we are joining it with a geometry join geometry with the previously combined chassis. Something to be aware of with the join geometry node. This multi-input socket is ordered. So if I plug my instances into the top here, then they will be added first and the rest of the combinations will be added to them, which means that if we have something like this, where we have our cab, these are all trailers, whichever one gets added to the top of the group is going to be first. So we would end up with this one being 0, 1, 2, and then we've got our cab here as well. So we might even end up with something which looks like 1, 2, 3, 0. And we want it to go the other way. Obviously, we want this to ascend in the opposite direction. So rather than coming into the top, we're going to make sure that we plug into the bottom. And you can see there that I can move that down to the bottom like this. So it's a bit confusing, but that is how this needs to work. These multi-input sockets are ordered. Okay, so now if we have a look on here, and we're going to be joining the chassis combined to that output. Now you can see that we have multiple chassis set by the number of iterations. If it goes down to 0, you can see that we lose all of them. And in fact, even at 1 or 2, you can see this loop is only creating trailers. So let's go ahead and join the original cab chassis on here as well. And again, remember these are ordered. We need the cab chassis to go in first, chassis combined second, and then these all go to the output. These are added in the correct order. Final thing that we want to do to this group is going to be to set our iterations on the front. And let's press N, bring up this side, drag that iterations above instance index, and this is going to be the trailer count. There we go. Now you can tab out and we can create trailers in here. Let me just run you through something. If I increase the position, if I move this around, it all follows nicely. But if I change the rotation on here, these all get added in the direction that they were created. So we also want this to follow the rotation of the previous trailer or cab, the previous chassis. So let's set this over to one side so that we can see it clearly as being offset. Go back into our create trailers, and just before the realize instances, let's just add an attribute, capture attribute. We're going to be capturing a vector on the instance domain, and we're looking for the instance rotation down here. This can just plug into there. And this attribute we can use directly in the instance on points rotation. And now it's all going to follow. So that just plugs across there like so. So that's now going into that instance on points node. Tab back out, make sure this rotation is following, and it is fantastic. So now we have trailers and cab. We have as many trailers as we want. Going off into the distance. If you want a really long train, you can do that. I'm going to set this to 3 for now, just so that we have something fun to work with. And there we go. So this is all working exactly how we want. Now, if you go back to your cab chassis or your trailer chassis, you can now go into that geometry nodes and modify it. So if I wanted to change the length, I apologize, this isn't showing up very clearly, but if I wanted to change the chassis length, everything is going to work with that. If I wanted to change the tow hitch offset, you can see that you can create that spacing in there as well. So all of these things are being read off the chassis. That is why we have access to them throughout the rest of the game, and that's why we've done it this way. Just means that we don't need to remember numbers and set things up in a very brittle way. It's always going to follow the chassis data. That's it for this session. We have now completely set up our chassis. Let's just reset the position there. So we have all of our chassis set up. It's working perfectly. The next thing that we want to actually address here is going to be, how do we make them move? How do we steer and accelerate and reverse and brake? All of that movement stuff is going to be coming in the next session, so join me then.